astronomical telescope, it is suggested to view a distant object. The incident rays fill the objective lens, whose diameter d as shown in the figure. If the angular magnification of the telescope is simple m, the diameter of the emergent beam is. Now we have to identify the given adjustment is normal adjustment of astronomical telescope because of parallel rays are coming towards the objective lens, and after passing objective and eyepiece lens again parallel rays are moving. Then we know that angular magnification, they have given simple m, but when studying we have get it as capital M. Angular magnification is focal length of objective lens divided by focal length of eyepiece lens. And then we can consider equiangular triangle. This length is focal length of objective, this length is focal length of eyepiece. This diameter is simple d. We have to find this diameter d1. Then we can get this triangle and this triangle equiangular. It means we can get ratio between corresponding sides. Then we can write d divided by f0 equals to d1 divided by fe. Then I will subject d1 fe over f4 times d. fe over f0 means reciprocal of this one. Then we can get it is 1 over m times d. d divided by m. Second one is the correct answer. The compound microscope objective that will be produced greater angular magnification with given eyepiece must be here. We know that for a compound microscope, f4 should be less than fe. Objective focal length of objective lens should be less than eyepiece length. Now they have given focal length of eyepiece lens is a constant value. Therefore, we have to find the focal length of eyepiece lens to get the maximum magnification. Then we have to decide the maximum Fe value. It means focal length of eyepiece should be maximum, and we know that for a compound microscope we are using convex lenses. Therefore, we have to use given maximum focal length 20 centimeters convex lens. Answer should be 2. As astronomical telescope in normal adjustment consists of two lenses of focal length 80 centimeters and 4 centimeters. Consider the following statement. Statement A. The eyepiece is the one with least power. We know that for a telescope, focal length of eyepiece lens should be less than focal length of objective lens. It is opposite to the microscope. Therefore, we have to select the minimum eyepiece length. And we know that lens power is 1 over focal length. When getting minimum focal length, we can get high power. Therefore, the eyepiece is the one with least power. No, it is false. It is incorrect. B. Angular magnification of telescope is 20. We know that for the normal adjustment, f4 divided by fe is the angular magnification. f4 divided by fe, f4 is the large focal length. It should be 80. Then 80 divided by 4, 20. Then it is correct. Then statement C, the separation of lenses is 84 centimeters. Yes, it is correct. We know that for the normal adjustment, it is like this. For the normal adjustment, parallel rays are moving as parallel rays after refraction through lenses. Therefore, for the normal adjustment, this length is objective focal length, this length is eyepiece focal length. Then sum of focal lengths should be equal to gap between two lenses. Then B and C are true. Correct statement. Then B and C are true. Fourth one is the correct answer. Consider the following statements made about microscopes and telescopes. Statement A. The magnifying power of compound microscope becomes maximum when the final image is formed at near point of time. We know that for any optical instrument, we can observe maximum magnifying power for the adjustment related to near point. Then A is correct. B. It is suitable to have an objective lens with a large diameter for astronomical telescopes used to study very distant objects. Yes, it is correct. We can get a large number of rays to the instrument by using a large diameter for the objective lens. C. Magnifying power of astronomical telescope becomes maximum when the final image formed infinity. No, it is false. We can obtain maximum magnifying power for the near point adjustment. Then A and B only true. Answer is 2. A converging lens of focal length 5 cm is used as magnifying lens. If the near point of eye is 25 cm, maximum magnifying power that can be achieved is. It is a simple microscope. For a simple microscope, magnifying power, it means angular magnification, is D divided by S plus 1. It is for the normal adjustment. For the abnormal adjustment, we can get only this one, M equals D of S. Now D value 25, focal length 5 plus 1. It is 6. Then answer is C. Number 16. Which of the following graphs best represent the variation of magnifying power, capital M, of a simple microscope with inverse of its focal length? It means 1 over S. We know that for the simple microscope, magnifying lens or simple microscope, magnifying power M equals D of F plus 1. They have not given corresponding adjustment, normal or abnormal especially. Therefore, we have to get that it is normal adjustment. Then M equals D times 1 over F plus 1. It is in the form Y equals mx plus 1. Then answer should be 1. Graph should be like this. Y axis M, x axis 1 over S. Answer is 1. The objective of an astronomical telescope has 60 centimeters focal length. When the telescope is adjusted to view objects for relaxed normal line, the distance between the lenses is 65. The angular magnification of instrument is. We know that for the relaxed eye means final image should be formed at infinity. It is normal adjustment of telescope. then we can get magnification, angular magnification is F0 divided by Fp. Focal length of objective lens divided by focal length of eyepiece lens. And we know that for the normal adjustment, sum of focal lengths should be equal to the distance between two lenses. It is given as 65. Then objective length, focal length of objective lens 60. Sum of focal length 65, it means eyepiece length 5. 60 divided by 5. Magnifying power is 12. Then fourth one is the correct answer. Consider the following statement regarding an astronomical telescope and a compound microscope. Part A. To obtain high magnification, the telescope must have objective length of long focal length and eyepiece length of short focal length. Yes, it is correct. We know that F4 should be greater than Fe. Then B. To obtain a high magnification, microscope must have an objective length of short focal length and eyepiece of long focal length. Yes, it is also correct. It is opposite to the telescope. Then C. At the normal adjustment of telescope, separation between lenses is equal to the sum of focal length of lenses. Yes, it is also correct. All A, B, C true. Then answer is 5. An astronomical telescope has eyepiece of focal length 5 centimeters. At normal adjustment, separation between eyepiece and objective is 85. It means objective focal length should be 80. The angular magnification of telescope at normal adjustment. Again we can get angular magnification F4 over Fp. If P is given as 5, we can obtain F4. Total length of the instrument is 85. It means F4 should be 80 because of sum of focal lengths is equal to the gap between two lenses. 80 divided by 5, 16. Then answer is 5. A simple microscope has a convex length of focal length 5 centimeters. The least distance of distinct vision 25 centimeters. The magnification of microscope in normal adjustment. For the normal adjustment of simple microscope, we can get m equals d of f plus 1. You have to remember this equation. d25 divided by focal length 5 plus 1. 25 divided by 5 plus 1 6. Then answer is 4.